Good afternoon. For demonstration purposes, we have developed proof of concept, a prototype device of AR/VR contact lens, smart contact lens that implements and showcases advanced, most critical patent pending technology that underlies our enabling very unique and revolutionary product. It consists primarily of two parts. One is the contact lens scaled up 1 to 7 approximately. It contains number of electro-optical components. It has a concave shaped optical shield optical component. It has an embedded see-through semi-transparent display here. It also contains a display controller, power supply module. At the moment, the device is fed by a pack of 4 batteries as such. And also it has a communication component through which the contact lens model receives and sends commands and information. Now, the contact lens device talks to the counter device, which is this. This is a Wi-Fi protocol-based circuitry. It connects through micro USB to a computer. Computer executes a program that we've developed that simulates the behavior of the embedded display, and you can see on computer. We will show you the large scale display. You control this device through that program, and basically actions taken on the program will be wirelessly fed to this embedded semi-transparent display. What are we trying to demonstrate with this demonstration device, the prototype? There is a fundamental problem with under-eye displays that we are solving, and the problem is this. Whenever you look at the stationary object, stationary image, or you read the text, we naturally perform multiple saccades so that we bring multiple portions of an image or an object in front of us, or different words in the text, in focus sequentially. And the reason for this is that the fundamentally human vision is divided into two parts. One is the peripheral view, which is the everything basically that we see, and at the center of our vision we have focused vision, which is up to 2 degrees of visual angle, very limiting in humans, and we can mentally digest and ingest information only that is present at the central point of our vision in focus. And hence we have to perform multiple saccades very quickly. They happen naturally, and in a short burst of time we jump through different parts of an image to bring different parts of an image in focus and ingest the totality of these images in our visual cortex. It basically stitches multiple focused images into one totality of visual perception. This is how our mind works, and this is how our eyes are being used. Now, if the display is embedded into contact lens, and contact lens is partially locked into position with the eye, whenever we try to accommodate and refocus in different part of an image, which is normally somewhere in peripheral view, what happens is that the contact lens moves with the eye. Every time you perform saccade, let's say you move your eye up left, and what happens is that the display embedded into the contact lens is going to shift in the same direction, and therefore an image overlaid is going to shift in the same direction, so we never accommodate or refocus. It's a fundamental problem that requires a solution, and we do propose a solution. This is a patent pending methodology and a system where we propose to shift responsibility of bringing parts of an image in focus from the eyes, which normally happens in our daily life, to the display. And the way to do this is to integrate several sensors into the contact lens that will track two things. We need to track focal length for some cases, and we always need to track orientational changes in the eyes. So motion sensor, orientation sensor, variety of those will do. And there are basically these are the two things that you need to compute and determine whether the user of the contact lens is attempting to accommodate and refocus on different part of an image. The system, once it detects that refocus attempt and accommodation attempt, it will have to recompute the disposition of an image in display so that the sought after portion of an image comes in focus at the center of display. So the entire image needs to proportionately shift from, if we are accommodating to left upper corner, the entire image needs to shift down and right. And we're going to again demonstrate how it's done. This is a fundamental problem that needs to be solved for AR/VR to be usable and practical and natural in a contact lens. So let us demonstrate how it works. So let me demonstrate how the system works. The demonstration piece has the piece of software that emulates the display of an embedded into the contact lens micro display. It is controlled by, as mentioned previously, by this communication device. The laptop tracks the software's changes in the software in the proposed hypothetical display that you see on the screen. Any change to the display on the screen gets serviced as a command to the contact lens, which is here. You can look at it through magnifying glass, and the contact lens will emulate what happens to the software. So through software you control the contact lens. Now again, as previously mentioned, the main idea here behind this invention is that we allow the user to use peripheral and focused view for under-eye display, and we enable it by tracking two different parameters: focal length for some cases, and always we need to know the orientational changes in the eye. By using these two parameters, we can identify and track attempted refocus and accommodation to a different part of an image overlaid on display. And we can allow the user to select and jump between different parts of peripheral, different parts of an image which are available in peripheral view. So let me demonstrate. At the moment you see in peripheral view, top left, temperature indicator 45 degrees, upper right corner time indicator, and at the bottom you have running news line. Imagine the user wants to look up to the right, to the left, and see what the temperature indicator is. The system would detect that action of the user and would reflectively change disposition of an image on display so that the sought after portion of display, which is temperature indicator, comes in focus, like so. So the entire image just shifted to the right and down. So let's see how did the contact lens display react. What happened is that temp 45 came in focus within the dashed line section of display. And the image shifted proportionately and in the direction diametrically opposed to the direction of attempted accommodation and refocus. So if the user would choose to refocus on running news line, what would happen is that the system would detect that there is a refocus, attempt to refocus and accommodate to running news line, and once the system detects the change, it recomputes disposition of an image in display and the display gets refreshed with new image that is reflective of what the user wants to look at, in such a way that a running news line comes in focus at the center of display. Now, this is a fundamental technique that needs to be, and technology that needs to be implemented in any future AR, VR enabled smart contact lens that will be utilizing not only the focused portion of human vision, but also peripheral vision, which is critical for most applications. In order for such technology to be useful and natural, the display that implements such capability will seem to be stationary relative to the eye, and will allow natural use of the contact lens and natural use of our eye. Now we'd like to build on this technique, which is patent pending technique, and we want to demonstrate you the system of control, which is very revolutionary and enables us to basically control everything that happens in our computer, assuming the interaction with computer is through the contact lens. The entire control is rendered through the use of the eye.
Now, we'll describe the system of control. Imagine a smart contact lens system running Windows 10 or iOS. It has embedded display into the smart contact substrate, which presents superimposed imagery to the user. There are a variety of UI components shown on display. How will the user of contact lens make the selection and activation of UI components? How will GUI events be generated? Haptics, mouse, joystick are out of the question. We could rely on gestures, which requires us to track hand movements. However, at RaayonNova, we propose a much more natural and robust solution. We have patented a unique and revolutionary technology, where we propose to render control of the entire system with an eye only, utilizing human eye as a pointing device.
On display, you can see member and AAA radio buttons and prime checkbox. These are selectable UI components. Below, you can see approve and deny buttons, which are selectable and triggerable. Triggerability implies, in this case, ability to generate an event within the system that will get percolated to event handler within the application, and appropriate action will be taken. Now, using the same technology, you can see, by the way, that the embedded display into the contact lens has the same image as what we have on our computer. Using the same technology that was described previously, the user can attempt to refocus on, for example, UI component prime if he wants to select a checkbox. And what's going to happen is that the system is going to use the user's eye as pointing device, and will allow the user to simply focus on the checkbox. Once the system detects attempt to refocus and accommodate to checkbox prime, the system will shift this position of an image display such that the checkbox prime comes in focus at the middle of display. And again, the dashed line, the circular dashed line denotes the portion of display that comes in focus on the retina of our eye. Everything that is within that section of display will be visible to the user in focus. Now, assuming that the user is done making selection, let's look at what's on embedded display. It's exactly that. Prime checkbox is in the middle of the embedded display. The user at the moment is happy with his selection and wants to press button approve. Again, the user will use his eye as pointing device, will lower his eyes to focus on approve button, and at that point the image will shift so that approve button is actually at the middle of display, and with additional triggering action, the approve button will get triggered, and event will be generated, and the system will process it appropriately. So this is a very novel, very revolutionary way of using your eyes pointing device that we propose, and we actually received a patent on this particular technology, and we intend to build our contact lens employing this technique. Thank you very much.